Ladies and gentlemen, hello and welcome back once again. It is 4 o'clock Eastern on a Tuesday, and for those of you in the world of enterprise IT, you know what that means. It's time once again for the briefing room. Yes, indeed, my name is Eric Cavanaugh. I will be your humble, if excitable host for the show that is designed to get down to brass tacks and peel away the marketing veneer to figure out what is going on in the world of enterprise computing. And today, we're right at the cutting edge, folks. I tell you what, this is one of the most fascinating concepts in enterprise information technology today. It's fundamentally changing everything, I would have to say. It is on the bleeding edge at the moment. There's no doubt about that, but I can tell you it's coming. It's coming like a fast-moving ship across the ocean, I suppose. A tight ship is the topic or the subject of today's webcast, the name, how containers and SDS optimize the enterprise. SDS stands for Software Defined Storage. Kind of a mouthful, but it's kind of a big deal too. So there's a slide about yours truly. Hit me up on Twitter at Eric_Cavanaugh. I'll be sure to mention you back or follow back. As many of you know, the mission of this whole program really is to reveal the essential characteristics of enterprise software. So we do that by hosting live analyst briefings. Today, we have a great group of presenters. Goodness gracious, we're going to hear from Blanchfield and a couple folks from Red Hat, including Stephen Watt and Sayan Saha. So let's talk about the topic in general. Virtual reality, well, isn't that just all the rage these days? Everybody's talking about augmented reality, virtual reality. In this context, we're talking about virtualized environments. So those who have been around for a little while know about SOA, the service-oriented architecture. And I remember first studying SOA, gosh, about 12 years ago, I suppose, and really trying to wrap my head around what they were talking about. I have been a developer myself, not too extensively, but for quite some time. I guess I was 14 or so when the Commodore 64 came out, and I did a couple programs in BASIC. So I had an understanding of code and how to write code and how to write subroutines and programs and build a bigger picture and so forth. And when the topic of SOA became prominent, which I guess arguably dates back to the 2000s, early 2000s, is when it started to take off, I really tried to understand what they were talking about. And when it finally dawned on me what this was all about, I realized this is a big deal. This is going to fundamentally change how software is designed and delivered. And that may or may not be good news for the big enterprise software vendors, because traditional closed source software, as they call it, well, it's been the mainstay for many years now. Big companies like IBM and Oracle and SAS and Informatica and all sorts of other folks have made a lot of money selling closed source software. But when you combine something like SOA, the service-oriented architecture, with open source software, it seems to me that's a pretty serious development, which is going to fundamentally change how software is designed and delivered and sold is the big key, right? So, well, what happened? So Linux, the open source operating system, came along really as a way to disrupt Microsoft's stranglehold on the operating system. And after that, we had this whole evolution of open source software, and it's a big deal. So today, of course, Linux is the foundation of most enterprise software applications, certainly in the analytics space, but also in a lot of other enterprise domains in terms of the computing that needs to get done. So I would argue that SOA really did win. You don't hear about it much anymore, and I think that's because it's just baked into how software gets built. Service orientation, so you have an architecture that enables the different services that can be ripped and replaced, mixed and matched, so on and so forth. So virtualization, of course, many of you know about, is a pretty serious deal as well, and also very foundationally changed how applications work. You virtualize servers. You used to have such a clean-cut separation between the storage and the compute and the applications and so forth, and virtualization came along and kind of created a whole new way of dealing with that. Well, my take on the whole concept of containers is that what we're seeing now is really a fusion of these two worlds. So containers can contain all kind of stuff. They can contain code, a little application, they can contain data. So it, again, is fundamentally changing the very foundation of how you build applications and run enterprise IT. So having said all that, which is a mouthful, I think it is a pretty big deal today. So we're going to hear from our data scientist calling in from Sydney, Australia. And we're also going to hear, I said, from Red Hat. So known leader in the open source software space. These guys really made an excellent move by focusing intently on enabling open source development, so on actually going out to organizations and helping them build their applications, helping them set up their open source environment and actually build applications around all that. And they have absolutely won that game. So we're going to hear from Steve Watt, Chief Architect at Red Hat, and from Sayan, Saha, Head of Product at Red Hat Gluster Storage. And with that, I'm going to hand it off to Stephen. Hold on, I'm handing you the ball right now. And we tweet with the hashtag of BriefR, so feel free to tweet about this. And with that, Stephen, take it away.
Thanks, Eric. So I'm going to start by sort of framing the larger picture. So, you know, what you see on this diagram is a series of columns around different dimensions of topics that we have to deal with in order to ship applications. And you know, if you sort of look at the rows, it sort of slices in time, right? So if you look at development models, we started off with the waterfall methodology, and then that became a bit too slow and cumbersome to ship products, and so we moved into a more iterative, shorter time frame model around agile, and over time the next iteration of agile was DevOps, where we sort of segmented developers and operations along the lines of applications rather than having sort of centralized functions. And then on application architecture, you know, we started off with these sort of monolithic applications that would run on single servers. And then we said, oh, that didn't work out too well because, you know, they'd start to, you know, consume more resources than a single server required, as well as it sort of didn't provide a great separation of concerns. And so we moved to an N-tier, or initially 3-tier and then N-tier model where, you know, you had a browser or a client, and then middle tier, and then a database tier. And that over time evolved into the service-oriented architecture model that Eric just teed up. And then that has specifically evolved into microservices, where specifically you have a sort of a service-oriented interface around a particular application, which is managed by its own DevOps team. And along those same lines, you know, if you look at our data centers or our server farms, you know, we started off with bare metal. And we thought, oh, this is great. But then over time, we realized, whoa, the server has way too many, you know, way too much CPU memory storage than any single application can consume. How can we carve this up more equitably? And so there was a software-based solution, which was virtual machines, that you created hypervisors that you could equitably distribute the resources into more discrete servers, which would be virtual machines. And over time, that has evolved into a container, which gives you a much more discrete, more granular sort of atomic packaging of an application with the host name, IP address, etc. And then for our applications, we started building them in-house with data centers, and over time, you know, maybe we moved some of those to, you know, a hosting provider, some of those to a public cloud, and then we've landed up where we sort of, where majority of the enterprise market are today, which is, you know, some things on-premise, some things in public cloud, maybe more than one public cloud. And lastly, the storage dimension, which is where we're sort of going to focus today, which, you know, we started with scale up, so very similar to the application side, which was monolithic. So you had, you know, one sort of storage server or an appliance that was hard to scale. That typically you bought a bigger appliance or a bigger server when you needed more storage with more storage capacity. And then that ran into the same resource issues that you had with the other ones, that they were either expensive or cumbersome to scale. And so you saw a move to scale out software-defined storage, which was much less expensive and was based on commodity infrastructure, so x86 boxes, to scale out using federated local disks. And then lastly, where we see today, where developers can then consume their storage at their own pace and provision their own storage, so you're able to consume storage as, you know, from a RESTful service or an API. So if you, as a developer, want a new EBS disk in Amazon, you know, you just go in as a developer and click, and you have your EBS disk. And you can provision that through the EC2 CLI just as easily, right? So I think when you step back and you sort of look at this broader picture as a whole, that you see a number of things that are emerging as trends and tools in the space, right? So you see containers as sort of the default packaging format. that merges with this model. So you have DevOps teams that are building applications that are packaged as containers. The applications themselves are consume multiple different services managed by different DevOps teams, and those services are containerized in the back end. So applications are constituted from an aggregation of services. By and large, the entire space is software defined, often offered as a software as a service model, and specifically there's a default to open. So we're not necessarily meaning open source, although there is a lot of open source in this space. I would say that, the foundation of all the paradigms here for most of the technologies is open source, but there's specifically a default to open. It's like, hey, I don't want to get locked in. How can I design my platform in such a way that allows for open communications between my different development teams, as well as basically allowing me to be able to move my application from on-premise to a particular cloud provider and then maybe change that cloud provider over the future. And so if we now dig in specifically to the containers, I think, you saw in 2013, Docker Inc. debuts with the Docker project, the open source project, and really simplified the ability to package applications and move those packages around, right? So, I always contend that Docker itself, Docker engine, is a packaging innovation, right? In the same way that in the past we had RPMs or dev files, which were packaging innovations, Docker is a packaging innovation that provides the ability to move applications a lot more easily around different hosts. In 2014, the Docker technology got extended support within various Linux operating systems. So you see in CentOS, Fedora, RHEL, Atomic Host, CoreOS, right? They're all built in support for Docker. And so you started to see this emergence of a container operating system and how you would design infrastructure to be able to run on containers. And at the same time, you also started to see people go, oh, that's great. Now that I've started containerizing things, just as an example, Des in the pre-chat was talking about how everything on his laptop is containerized, right? So if that's the case, he's running many, many, many containers, right? And if you're doing that for many, many different applications across your whole company, you start running into this issue of, oh, how do I manage all of these things? When do I know when one of them died or what host it's running on, right? And so you have this emergence of container orchestrators, right, and which are a control plane or a command center for running the different containers that you have for all your different applications across your cluster. And so you have Kubernetes project or Origin, Deus, Mesos. These are all examples of container orchestrator control planes. And so in 2015, you really started to see this move maybe out of the innovator a little bit more into the early adopter, some brave souls in the early majority, where you started to see both Docker and Kubernetes used in production. Grow specifically among startups and web scale companies. So Google has the GKE container service, right? 2015 was the year that OpenShift, which is Red Hat's container platform product, re-platformed on Kubernetes, right? And so we had on-premise customers like Amadeus that were building containerized applications and running them inside OpenShift, right? And in 2016, we're really starting to see container interest peak among, peak is in P-I-Q-U-E, peak the interest of enterprises and on-premise customers, and they're moving beyond those initial pilots to actually running some applications in production, right? So it's still early days, but there's definitely some very compelling references on this. Like, for example, Pokemon Go, which is a very popular application that many of us have seen folks buried with their nose in their tablets or their phone wandering around neighborhoods, right? That's actually powered by Kubernetes, which is core technology behind OpenShift. So if I try and take these technologies and line them back up and say, what would I say to your CIO or, director of IT about why all of this is relevant? I would say that we're in a space where technologies are coming out faster and faster and faster. And we need platform technologies that allow us to introduce and experiment with these technologies and then identify the ones that we want, and build on them faster and faster. So there's a tension between innovation and agility that needs to be addressed. And I'd argue that really containers and container platforms really are the best that the industry has to offer in providing the ability for us to introduce new products and new technologies in a safe, manageable format. And so I think those two really allow digital transformation and app modernization. And so, you know, Red Hat specifically has a whole stack that's dedicated to this, right? So, you know, whether you're running physical infrastructure, bare metal, you're using hypervisors, virtual machines, you might be running, you know, OpenStack cloud provider on premise, or using Amazon or Google or Azure in the public cloud. We have, you know, our enterprise-grade container OS, so we have both RHEL and RHEL Atomic. RHEL Atomic being a version of RHEL that's specifically optimized for containers. So it basically expects everything to run on it as a container, where classic RHEL, you have the option of either running something as a container or not. And then, you know, on top of that, we have, you know, our OpenShift product that that basically provides the ability to, you know, run Kubernetes across your cluster infrastructure on RHEL or RHEL Atomic, and that does container scheduling and orchestration, connects your containers to a variety of different storage platforms like our container native storage, provides a container registry, provides software-defined network overlay, security for your containers. In addition, there's, you know, container management dimensions in there, so we're able to do monitoring, capacity policies, for example, you know, on the storage dimension, you know, how much storage can somebody provision, what type of storage can they provision, etc. So this is hooked into CloudForms, which is our cloud management product portfolio. And in addition, we also have, you know, we also cater to the development lifecycle. So if you are building applications, you know, we have source to image. So basically, you can, you know, choose GitHub. You know, when you do a push, it will actually produce the image. You know, produce the commits, push and roll the container, and then deploy that within Kubernetes, you know, and run it within OpenShift. We have at the PaaS layer, XPaaS, which is a variety of our middleware portfolio that can run within OpenShift as add-on services. So services around web and mobile, data, you know, different integration services, business automation. And, you know, these are typically pulled from a Red Hat registry, which is a secure container registry where you can leverage different technologies like CloudForms and Ansible, Satellite, et cetera, to make use of these. So, you know, just to sort of step back and you know, walk through, again, how some of these products are used along with our storage portfolio, you know, there's a shipping analogy that we've put together, right? And so, if you recall, when I first started, I sort of explained that, you know, containers are a packaging innovation, right? And it packages applications according to a particular format. And so there are, you know, advantages to packaging applications in format because it's standardized, and basically the entire sort of ecosystem around that thing can be optimized to be able to move packages in that format, right? And so the analogy is a shipping container is sort of like Docker, right? So you can take your goods and you can put them inside the shipping container, and then it's super easy to move to a shipping container because the entire ecosystem is designed to be able to move shipping containers, right? And so, you know, then you have like, okay, great, like I've got my shipping container, I now want to like, you know, transport it and use it. And so that's sort of like RHEL or RHEL Atomic Host, which is like the actual container ship, right? So that you can put the containers on the ship, and the ship is designed to be able to stack as many containers as possible. And so like the ship is optimized for that. And so you can both move containers onto the ship and off the ship very easily, but also like that ship is designed specifically to stack as many containers as possible. So for you server folks, that means good utilization, right? And so that's our operating system. And then, you know, you sometimes have different types of ships. You have big ships, small ships. The amount of ships that are available and what their capacity are differs, right? And so that's sort of the platform, right? So you might, one ship might be able to contain 20 containers where another might be able to contain 500, right? You need a scheduler to sort of decide, well, I've got this container, which ship does it go on? And that's essentially OpenShift, which is our Kubernetes distribution, right? And that basically provides the platform for moving your containers around the cluster. And then lastly, there's the stuff inside the container, right? The actual content, right? Some of the stuff, you might not care if it's perishable or ephemeral, but other things are like really important, like, your flat screen TV or something like that, that you really want to save and make sure it's durable and persistent. So we actually provide ways to be able to run containers, but as you use them, make sure that the information within the container is stored in a place that's persistent and durable and long-lived beyond when the container dies, and it comes back up again and to be able to reattach to that storage. So with that, I'm going to hand the presentation over to my colleague, Sayan.
Good afternoon, everybody. Thanks, Steve, for that excellent introduction. I'll take over from where Steve left off, where he provided us the big picture containers, where they fit in, and what folks are trying to do with them. The other important topic of this briefing is what to do with storage for containers. As Steve mentioned, containers provided, Docker provided rather, a very nice packaging abstraction that helps you to go move containers from one host to another host. Now, just because you did that doesn't mean that the need for persistent storage for containers or applications go away. So the key thing in that is how containers, do storage. What we have realized is basically there is a much greater there's a greater abstraction between storage and applications because of the users of the API, or being more of an API-driven model. This allows storage to be abstracted better and be flexibly embedded into different forms that you couldn't do before. So the greater abstraction helps. The other thing that we have also experienced is developers, who are the ones who actually need storage. They literally want storage to be invisible. They would rather not have storage or deal with it. So one thing that they do not want to do is basically, encounter lengthy provisioning cycles for storage, where they go to their storage admin, ask for, 200 gigs of space for their development, which might take days to get provisioned. They don't want to do that. They want absolute frictionless and seamless storage availability. We also realized that, traditional storage appliance cannot offer the speed and agility required, in app-centric IT. What we are asking for is developers asking for small pieces of storage, 100 gigs, 50 gigs, 200 gigs, 1 terabyte, etc., which they want, which needs to be provisioned really fast, and so that they can start using it and mount it on different hosts. And that's definitely not how traditional storage platforms are built or were built when they were conceived. So there's a fundamental gap between how developers want storage and what storage is there in the marketplace today. So moving on to the next slide, where, I think we kind of established already that containers are a different packaging format, as Steve said. But just because you put containers, put applications in a different packaging format doesn't mean that they don't need the persistent storage anymore. An example is a MySQL database. You could put MySQL in a container, but it still needs this data stored that needs to be persistent. So the container revolution started with stateless apps, but soon enterprises realized that in order to use containers, they'll need persistent storage, because 90% of enterprise, or even more of those, need persistent storage. And in this graph, we kind of show what kind of apps, are being containerized. And most of this, if not all of this, need some kind of storage, persistent storage to store their data and state. So let's kind of give you a brief timeline on what we have been doing in Red Hat with persistent storage for containers, especially pertaining to Red Hat cluster storage. Last year, in November of 2015, we brought the first incarnation of Red Hat cluster storage in the market behind OpenShift. OpenShift is our container platform, as Steve talked about, where we shipped a driver for latest Red Hat cluster storage inside OpenShift. The big thing here was you would be able to access Red Hat cluster storage over the network from containerized application containers within OpenShift. You know, this was mostly, it's very similar to what you guys are probably familiar with in terms of serving out storage from appliances over the network. But Red Hat Cluster was one of the first platforms that actually had a driver for Kubernetes where it could be accessed over the network. Next, in spring of this year, actually this calendar year, we actually containerized Red Hat Cluster. What that means is we put Red Hat Cluster inside a container so that it could run inside a Docker container and serve out storage on the local host. So it had all of its functionality as it provides as a storage platform, but it could run inside a container, which was pretty handy when we released this new platform, which we call Container Native Storage, in summer of this year, where we started running Red Hat Cluster Storage as containers inside Red Hat's OpenShift platform. This was pretty groundbreaking, as you can see in the next slide, where we basically are now running, this solution is actually generally available right now. You are now running Red Hat Cluster Storage containers inside the OpenShift platform, which provides storage services, you know. So you all know, or most of you know, that containers can provide compute services, but we now have containers that can actually provide storage services. The net is we basically have integrated a complete, fully featured storage platform inside Red Hat's OpenShift product, which is a container platform. So you can technically buy, you know, OpenShift with a storage platform inside it, you know. The big advantage is obviously, you know, you run inside OpenShift in a container in Kubernetes pods, and you run along with application containers. You don't need a separate cluster. But let me kind of, you know, go through those advantages a little bit more in detail. You know, you've got a unified cluster in which you can run, you know, on some hosts, compute containers like your regular containers, WordPress, Nginx, MySQL, and in some of the hosts you can run storage containers. If you so want, you can actually run a mix of those in certain hosts. So you have the complete flexibility on determining whether you want to run compute containers together with storage containers or separately or mixed up. It's totally up to you. And you can designate a certain number of hosts where you can say, well, I have these beefy storage nodes. They will be running the storage containers. I have these compute nodes that will run the compute containers, and all of these are managed and controlled from one control point. You have a unified scheduler in form of Kubernetes inside OpenShift, which you can use to deploy your storage containers, just like you would deploy a compute container. So these things run together, you know, and can be basically deployed and provisioned using the same workflow. So gone are the days where you would have to, you know, you would have to call your storage admin where you have to call them, okay, I want a LUN, or I want a volume in a filer, and please provision me, and these are my storage characteristics, and that's not. You just storage, you provision storage like you storage provision compute. We'll have a unified management pane. What basically that means is you'll be able to see your compute and storage containers in one pane, so you don't have to go through multiple consoles to figure out, okay, well, how is your storage working and how is your compute working, are they in sync, etc. We have a consistent upgrade procedure, so upgrading storage is as simple as just upgrading the storage container across the cluster. So you have version 1 of a cluster container, you know, for example, when, you know, version V2 of cluster comes out, you just go and deploy, Kubernetes deploy a new container, and it's just upgraded. And then last but not the least, you have a single point of support, because both OpenShift and Cluster are technologies that Red Hat supports and productizes, etc. So you don't need, you know, two vendors. You can call Red Hat, and it's all integrated, tightly integrated platform altogether, and you got one throat to choke. So again, going through a little bit, detail, yes, it's wonderful that you can run storage containers, storage inside a container, and they can run with compute containers side by side. You've got convergence. You don't need to use a appliance, et cetera, blah, blah, blah. That's all good. You understand that. But what does the storage platform actually do? It is not a stripped, pared down storage platform. It's actually a storage platform that's been in development for more than 10 years now. It's mature. It's used in several thousands of deployments, and it's fully featured. So you don't get, just because it's running in a container, you're not getting a stripped down storage platform that can only take some reads and writes. You actually get a fully featured set of data services, including snapshotting, cloning, quotas, geo-replication, tiering, erasure coding, bitrot detection, compression and dedupe via partner, security, at-rest encryption, SE Linux, self-healing, all of the goodness that you get with a good distributed scale-out storage platform is actually integrated in the containers themselves. So it's really powerful. You now have a storage platform that runs in a container alongside compute containers and provides you a host of features that you expect from a traditional storage platform. It's really like the best of the two worlds. That ends my session. I'll try to now give Eric the control.
All right, let me hand it over to Des. And Des, we have some great questions already from the audience. So by all means, both Sayan and Stephen, check that out in the Q&A panel and get ready for those after Des does his thing. Take it away.
I'm very excited to see some of the questions coming through. So there are a number of key things that I want to leave everyone with today. One of my focuses on any time we present on something, any topic we talk about, I want everyone to take at least one idea away that you can actually put into practice, something you can actually implement. And so I'm going to lead us through a very quick overview of kind of the whole concept of containers in a very similar way that our associates from Red Hat have, and I'm going to use the same shipping model. And then I'm going to jump into how we got to here very, very quickly, and why I believe this has completely transformed the way we're approaching everything. The thing I want to leave you with, though, and I'm going to give it to you now and then show you how I'm going to wrap up into that point, and that is that everything is going to become cloud native. And that means that all systems, all platforms, all applications, all tools are going to assume that you can provide services through an API, you can scale quickly, and you can burst. So all modern development, all modern platforms are going to come along where when you see something on the screen, there's going to be an assumption in the very short term that you don't need the compute workload on your local device, whether it's a phone or a tablet or a laptop or a desktop. The assumption is going to be, excuse me, that you have access to some infrastructure on-premise, or you've got access to a back-end environment through cloud or some private, hybrid, or community or public cloud. And that if you haven't, you can sign up to one. And we've seen that transition take place with the likes of Office 365, where we used to run the GUI apps, and then all of a sudden everything became cloudified. So that's the thing I want to leave you with, but I'm going to lead you to that key point, because it's a really salient point when we think about how we're going to deploy new development, new platforms, and move data around, particularly in storage. So to that point, in 1956, a gentleman called Malcolm McLean completely transformed shipping and logistics when he introduced this concept of a standard format for what we consider a bimodal container. Prior to this happening, shipping around the world of food and livestock, and if I was moving house, I'd have to put everything in cardboard boxes or wooden boxes, and those boxes were made bespoke, and it was a nightmare. So this gentleman came along with these things, and this is a 12-foot shipping container. We're pretty familiar with these things. There's a 20-foot one, and they go out to my all-time favorite, which is the 40-foot container, and they're used for almost everything. In fact, I've seen people in Australia turn them into swimming pools. I've seen them turn into little roadside cafes. I've personally been involved in putting data centers into them and then putting these on the roofs of buildings with computer rooms in them for the likes of banks and government. And you can see that, these things, by being a standard shape and size and format, we can build infrastructure to move them around. All the logistics and planning and management is easy now because we've got a standard approach to, even if you're just moving a single box or a car or something, you put it in the container and everything's built around that. And it's simplified the entire world of logistics to the point where, things moving around got there safely in one piece. We didn't have broken boxes anymore. Ships were redesigned, the entire infrastructure platform, and it's exactly the same in IT infrastructure and business infrastructure. Ships are small, medium, large, extra large, very, very big and ridiculously large, like this thing that we're seeing here. And in fact, the largest ship on the planet now, and this thing is called the EEE. It's 400 meters long. So it's almost half a kilometer long. It holds about 18,000 containers of standard shape. If you were to line these containers end to end with a fully loaded EEE, they'd be something like 110 kilometers long. So that gives you some scale of what we can do when we get to a standard platform and we change the way that the infrastructure around that platform expects things to behave. And an entire industry is built around that, so much so that when you build a new building now these days, people don't build the toilets and kitchens and general open areas anymore. They buy them pre-built. And so, for example, in China, they manufacture kitchens and toilets or bathrooms in shipping containers. And when you build a building, you crane containers to the roof, you drop it down the center of the building, and you push them into place, and then you basically toss the container away. And that's how they build buildings very quickly. So you can imagine that, not just shipping things around the planet, but also now everything down to the buildings we work in are impacted positively by this because we can speed things up and things get cheaper to make. But of course, standards are a great thing, but sometimes people don't quite get the memo. So it's a bit of a chuckle, even though we make great efforts to do great things, sometimes people apply slightly different approaches to how they ship their containers around. And I saw this on the web the other day, and I just had to use it. This is a real-world implementation of shipping containers in a non-standard format, but it works. So, as our associates from Red Hat outlined, the ISO standard for shipping containers is a perfect analogy for the modern application container. Everything that the shipping container for physical goods did for logistics and transforming the way that things moved around the world, that's exactly what we've seen now in the technology space, in computing and the way applications are developed and the way data is moved around. We've seen this whole concept change very quickly, though, and to put this in context, in less than a lifetime, data storage has gone from something called the punch card to blocks and objects in containers. So think about the speed at which this transformation and innovation has taken place. In my lifetime, I'm the grand old age of 49, when I was at college, we used to get these punch cards, and we would punch holes in them with pens and ship them off to a data center, and people would try and run them, and we'd write programs, and then we'd store data on them. So in my lifetime, we've gone from a cardboard card you could hold in your hands, and you'd ideally use a typewriting device that would punch holes into them, to the point where now data and applications move around this, and this virtual world so fast that things run in milliseconds, if not less. And what's happened is we've had to change our thinking where, in the days of punch cards, when they were created, people used them originally in the form of a holograph card to do things like elections. But that would take 10 years. To do a census. To do a census in the US is a 10 or 11-year process to analyze the data. But over time, it's gone from, decades to years, years to months, months to days, et cetera. And now everything's real time. And most importantly, everything is always on. So, in one lifetime, we've seen this dramatic shift in the way that data is considered and thought of and processing around that information management. A couple of really big things happened to make that possible as well. So the cost of disk fell to nearly zero. Here's a couple of J-curves. The one on the left and right are approximately a decade each. So, disk space on a per gigabyte basis has gone from, nearly $380,000 US, nearly $400,000 per gigabyte, to the point where now it's sort of down to, approximately 4 cents per gig per month for different types of storage in the cloud. The same happened to memory. At one point, you would pay something in the order of about $6.3 million US for a gigabyte of RAM. These days, a gigabyte of RAM on a monthly basis is down to something like $4 US. And each of these J curves is the reduction in cost over a decade each, so that's about 20 years worth of cost reduction there. These two things have made it possible to do some very exciting things. There's some other things that have come about as well, and that is that the way we consume things and the concept of digital disruption, where technology has made a whole bunch of things possible, and so now we're filling that gap with what we can actually do with it. So real-time cybersecurity, fraud detection, anti-spam. Once upon a time, the internet was just clogged with unwanted email. These days, we almost don't get any spam because systems can find spam and detect it so fast. Any money laundering, know your client for banking, wealth management. So we've all seen social networks, and we've seen marketing and advertising technology transformed to the point where it now uses cognitive computing to figure out whether we're happy and sad. And social networks even make us feel happy and sad deliberately as experiments to see whether we spend more when we're happy and sad. Organizations have learned now to leverage these technologies to deal with things like corporate compliance and regulatory compliance, because we've had things like the GFC and so forth impact us, and we've had to deal with them. We've seen permanently connected devices like mobile devices, tablets, and payment platforms that happen instantly, in-game spending, for example. And we heard mention of the likes of Pokemon, and there are many other games where, in real time, money moves around in a virtual sense in game money or Facebook money, or it's, game money to real money. And I've had to deal with myself when my son downloads a free game, and then all of a sudden we realize that about $100 is gone and it's accidentally been linked to a credit card. And we've got this whole thing about real-time everything, recommendation engines, everything that I do now, there's something behind. There's often a whole stack of things behind trying to figure out what I'm doing and recommend things to me. The Fitbit generation is the term that I've sort of used to describe this always on, always tracking. So my phone tells me how many steps I've done. My little wrist device, which I won't name the brand of, tells me how many steps I've done. There's all this stuff that tells us everything that's going on around us. We also have the disruption of what we call a celebrity experience. Customers now want to be treated as the most important one person you're dealing with, and they'd like it to be integrated with their social experience as well, so they can find out whether their friends like or dislike you. So the scale at which this is running at and the complexity that's existing in these worlds now, the volume of data that's moving around is quite eye-watering. But the issue we had was the old technology wasn't container ready. In the early days of mainframes, we had LPARs, and we had VMS and Solaris had sort of container concepts, and then the next generation was sort of what we called jails and user mode Linux, and a thing called OpenVZ, where we could containerize applications, but they were quite fat and heavy. And then we got to the point where application layer sort of dealt with some of the problems. So we had Java virtual machines, we had platforms like Tomcat, and JBoss, where we could actually put applications in containers like little zip files or WAR files, we call them, but it didn't quite cut the mustard because we were only moving the business logic around. The data still had to sit in a file system and be shared. And so we focused on shifting hardware to virtual machines, and that was great because we had much more powerful compute. But early on, we had 32-bit CPUs, so virtualization was very hard. We didn't really do a good job of it. We couldn't do a good job of it. So we focused on going very big with symmetric multiprocessing. Then the semiconductor industries caught up with the demand for mobile devices, and things changed. Now that image, just to give you an idea of the scale we're talking about, that image you're seeing on the right there, that's something in a game called Minecraft, where you sit and build the world in little 3D blocks. Somebody built a 4-bit CPU in a 3D game on an iPad. So you can actually go and download that little mod and watch a 4-bit CPU running in real time doing adds and divides and multiplications and subtractions in a 3D game. And that whole game runs in a container, believe it or not. So the semiconductor world caught up. So the new tech now is 110% container ready. Virtualization has moved from software to hardware. It's built into the CPU. 64-bit CPUs come with virtualization built in natively. And this makes what we do in containerization possible now, because things can move very quickly in a very small form. We also realized that to go big, we had to go small, and that was that going vertical, scaling vertical didn't do the job anymore. Stacking lots of big machines together just didn't cut the mustard. So we went down to little tiny machines. We broke everything down to little tiny compartments and did lots of them. We learned to deal with a lot of the scale around what became platform as a service with a couple of things like Heroku and Engine Yard in early days. And then we had some interesting things come about where open source made some of this transformation possible, because we get to the source code and we could change things. In fact, there's a couple of really great quotes from a friend of mine called Randy Bias, who popularized this concept. But I think it was originally a guy called Bill Baker who said that once upon a time we treated computers like pets. You know, we'd build physical machines or virtual machines, and we'd love them and hug them and put our arms around them, and we didn't want them to die. Nowadays, we consider technology to be like cattle, and containers are very much like cattle. When we instantiate a container, we don't care about it. We give it a number, and when it's finished, we kill it. And that completely transforms the way we think about how we develop software and how we implement services. So we've moved from physical service of VMs to now apps, and the next challenge is how do we tackle the storage world around that, because once you've got to that scale and things move very quickly, if something's just sitting in memory and doing a bit of compute and business logic, what happened to the data and what happened to storage? And that became a real headache for us. So then along came the next generation of app container and container technologies like Docker and Kubernetes, and particularly OpenShift. So containers are here, and they're here to stay this time. We didn't quite get them right on mainframe. We didn't quite get them right mid-range. We certainly didn't get them right in the micro world of the Unixes and so forth, but we've definitely got them right now in the world of cloud and big data. So much so that on the right-hand side of that image, these are literally off the rack, if you'll pardon the pun, nearly half a petabyte, 1 petabyte, and 2 petabytes, so small, medium, and large. These platforms, you can buy them. You can literally buy them on a credit card now almost. I mean, they're not quite that cheap, but you could literally buy them online, and they will ship you up to 2 petabytes in a rack. And that rack could run up to 60,000 different virtual machines, which can run hundreds of thousands of containers. So we've got these things now that we work with continuous development, continuous improvement. We've shifted from very old school frameworks and methodologies to DevOps and everything as a service. We now expect containers and microservices to be the norm. And in fact, I think it was Mark Andreessen who was famously quoted as saying that software ate the world. Well, it has definitely eaten the world, and in fact, APIs are king. We expect everything to be composable now, and we need to be able to, and we expect it to be orchestratable. I want to just write a recipe, as it were, or a series of rules, or a script that can reach out and build things on demand and do it instantly, and then kill it at the very end. Because if I can describe the outcome I want in a script and an automated process of some form, then I don't want to have to pay for it all the time. I only want to pay for it when it's up. We learned that we had to scale horizontally rather than vertically to get things to go very, very, very big. And we could do that in burst on demand. And also hardware now is a mere commodity. We no longer focus on the hardware layer. We're now focused on the software layer and then even services. Everything that we're building these days, in my view, is what I call a cloud native. And that is that the apps, and particularly things that are running in containers, they don't really want to know, and I think the term abstraction is the best way to describe it. They don't want to know about the server. They don't want to know about the operating system necessarily. Cloud native apps expect to be able to reach out and scale up and down and left and right horizontally as and when they need. And we're seeing this with smartphone. If you go to a website and you want to buy tickets to a show for tomorrow, you don't want to worry about it being slow or fast because the back end infrastructure, someone hasn't stacked up enough service for the storage and compute. You expect it to instantly respond, and to do that, you might have 500,000 people trying to register for something. And the only way that can happen is if the back-end infrastructure is a native cloud environment, and the same applies to the front end now. If I'm doing analytics on a platform at a tablet level, I don't have the grunt in the tablet to do all the workload. I'm going to burst it out to something in the back end, and this is where container technology has completely transformed the way that's made possible. It's the same with big data. Everything we do these days is all about me, and I want real-time analytics to tell me whether someone else has bought something that I just looked at or whether it had a good or bad experience. The classic eBay, 3 to 5, 10 stars, or I won't buy it. And again, the scale and speed that big data and analytics is happening at can't be done in a bare bones format. We expect it to all be containerized. And then we've got this freight train coming at us of the Internet of Things, which is where everything is going to be streaming. So we don't just turn it off and on. It's just going to constantly stream data at us, and we decide whether we want to catch that data and process and analyze it. And this is going to take things to yet another layer of speed and volume. And again, further demand and drive for cloud native, real-time analytic big data, and containerized everything. And underneath all of that, a storage platform that can cope with things being instantiated instantly and quickly and then burnt down at the end. And so that brings me to my key point around this whole discussion today, and that is that today with modern container technologies being what they are, those who adopt them early, and particularly for the types of challenges we're facing now in storage and moving stuff around different types of containerized, virtualized compute, those organizations that adopt these technologies now are going to get a significant advantage over their competitors. And in some cases, there was a quote once where someone said that those who adopt technology early can invariably get such a significant advantage over their competitors that competitors may actually not catch up. So remember, I kicked off and I wanted you to take one thing away from this, and that is just to circle back that everything's going to be cloud native. We're expecting everything to be sort of composable at API level, but storage is the biggest challenge for us all, and I believe we're about to go into some Q&A now around just, how that can apply to some of the questions that people are asking around their platforms, around Windows environments, Linux environments, cloud environments, analytics and big data environments. But it very much is the case in my view that this is something that is already here, it's already working, it's already safe and secure and stable, and now is the time to get on board, not to just sit at the sidelines and hope somebody else is going to demonstrate why the value is there. And with that, Eric, I'd like to tuck back to you for some of the questions that I've seen come through, which are fantastic, and I've got a couple myself as well.
No, why don't you just take it away?
Sure. Well, actually, let me throw it back to our associates from Red Hat. I guess, we've covered it in a broad sense, but maybe if you could just very, very quickly, in one sentence even, just highlight the key takeaways with regard to the key benefits that software-defined storage has brought to the market, and particularly with what you've offered today, in comparison to traditional storage appliances. Once upon a time, we would either buy a network-attached storage device or a storage area network of some form, whether it's from hundreds of gigs or terabytes or even petabytes. What are the sort of in a one-liner, if you can, what are the key takeaways with regard to the benefits that software-defined storage is now offering over those, what we're now calling legacy storage platforms?
I think I can take that. The key benefit that I see is flexibility and programmability of storage. Flexibility in deployment and programmability for allowing developers to actually start using storage the way they want it to be, which is not in a frictionless manner. And at the same time, providing the feature set that people expect from a traditional or a classic storage platform. Why these three things are key is just because it is how the new workloads, modern workloads, are built differently, as you said, as microservices and things like that, and they're not built like the way they used to be built. So you basically need modern storage for modern workloads. Trying to use classic storage for modern workloads is trying to basically trying to fit a square peg in a round hole.
Yeah. Yes, absolutely. This is something that comes up conversationally both at boardroom level and at stand-ups and scrums in my world, and that is that people are constantly struggling to cope with the challenge of going from legacy enterprise apps in sort of the old world to very agile and rapid deployment of new exciting features and tools. And then there's this gap historically of how to bridge those two worlds. How do I go from traditional block storage on my NAS or SAN to what I'm now doing in my non-persistent containerized apps that just burst as and when I need them. So I guess that then brings me to my next question that I sort of scribbled down as we were talking, is when you had this slide that I just brought back up about how containers need persistent storage. As a developer historically, myself coming particularly from a systems development background, I used to have to worry a lot about infrastructure. In fact, I deliberately taught myself all the core fundamental bits of how the computer technology worked, how the hardware worked, how the network and security worked, because I was constantly frustrated by the fact that I had to continually go back to operations staff or architectural staff and say, how am I going to grab another gig of data or terabyte of data over time? But as a developer these days, we tend not to worry so much about the infrastructure, do we? So can you maybe just highlight your journey so far on how you sort of got to the point where developers now don't have to bother worrying too much about the infrastructure and where their apps are being deployed, but now they can sort of focus on that whole seamless integration and the underlying storage for their containers and containerized apps?
Yeah, I can take that. This is Steve. Yeah, I think we have bytecode interpreters to thank for that. Where basically Java got folks, just not really caring about what their application runs on. You know, if it compiled in the JVM, it would run on the JRE, and, you know, as long as the JRE could be installed somewhere, it would just run. And I think that was very liberating for developers. And, you know, I think they're habituated to that, and as well they should be. You know, I think technology exists to, you know, for productivity. And so, you know, I think as people that are innovating around application platforms, that we should really help developers focus on the things that are important, which are just, you know, how do I automate some piece of process, or, you know, build something that will help me do something more efficiently, you know, and so, you know, that's essentially at the heart of where containers come from, and a lot of this whole microservices, agile DevOps methodology is like, how can we remove impediments? Someone wants to build something, like, now it's like nobody needs to like set up a source code repository. They just go to GitHub. They just, you know, start building the application. They can share it, collaborate, and then they can just push, and it'll build to a container and ship in production, you know, on some sort of platform or container as a service. So I think, you know, we're really user experience focused. It might surprise folks to think that a sort of a Linux platform vendor is focused on you know, user experience, but we are. And we really are trying to make it easier and easier for developers to be productive on our platform.
That, yeah, and I guess that leads me to my next question, I guess, and that is that you're recently ranked by Gartner, from memory, on the top end of the relevant quadrant, both as a visionary as well as somebody that actually had delivered the technology, specifically object storage in one particular space. Can you maybe just give us a bit of a background on kind of how that came about? What kind of inspired the organization, the team behind it, sort of push towards that space and realize that, you know, things are going towards objects, things are going to this scale, and then to kind of get the buy-in from the business to make good on that promise?
Yeah, I think I can take that question. I mean, I think it's a huge testament, you know, to the progress that we have made in Red Hat with software-defined storage in the last 4 or 5 years. You know, when we started off back 4 or 5 years ago, it was mostly a cost play, where we would say, well, we can do software-defined storage. We can do, basically, we'll put storage software on hardware, and it's going to be, you know, more cost-effective than buying appliances from traditional storage vendors. But over the years, this has become more of an innovation play. We are finding more and more that people are turning to software-defined storage is because, why people are doing it is because they actually are realizing that for certain workloads, software-defined storage is better. It's more flexible, it scales better, it doesn't have any dependency on a specific hardware platform, so you can move things around, you're not locked to some appliance. So, you know, some of this was driven from the compute world, you know, the emergence of OpenStack and Kubernetes and, you know, basically containerized workloads and all of that stuff, I think helped us a lot, because if you are going against traditional enterprise workloads, you know, then you always have to kind of start disrupting something that's already well established. But when new workloads started coming in, which actually helped the cause of software-defined storage, we saw the shift in enterprise customers now seriously looking at software-defined storage for their newer workloads, as opposed to just using it as a more cost-effective way of, you know, compared to of storing data compared to what they have today.
And I guess, you know, we were talking about this in the pre-show, but just to recap for folks who weren't there was a couple of great comments around the fact that the on-premise world in the traditional enterprise space doesn't always have the free infrastructure or the scale to kind of prove out these models. And I think it was a term that Google has sort of come to these conferences and developer forums and design forums and kind of share their experience of what they've done at scale, a scale we can only imagine. And then a lot of that thinking comes through the development community, the design community, and then when organizations like yours sort of grab that and then bring it into, you know, the light of day as a real thing and then package it up. And I think you commented earlier around, you know, standard installer for model platforms that become something that we can then get behind, because at the end of the day, I saw a great comment coming through earlier from somebody who said they're not a development shop. I think it was actually someone locally here in Australia who said that they're not a development shop, and so they, how is this going to apply? And I think the answer to that was this is going to apply because you're packaging up these open source technologies, these large-scale technologies, particularly object storage and scalable object storage, so that everyday consumers can get these things and deploy them at scale. With that in mind, I guess my last question before we throw to some of the audience things, maybe just quickly in 30 seconds, just summarize if you can some of the key best practices around design patterns. So for folk who are just getting their finger, their toe in the water with this stuff, getting their fingers on it, playing with it, some general thoughts quickly on best approach, best practices, general design patterns that you've seen emerge through medium to large size enterprises in particular, when they start to look at adopting containers and deploying storage in their container environments, and how does this sort of go as a journey? Where do they start? What are the key things they need to think about? Potentially some pitfalls, and where does that get them in the short term?
Yeah, I can take that. This is Steve. So I think most folks' experience is that they start with one or two containers. They containerize their first Hello World app, and then they start containerizing a few apps, and then they might choose to run one or two apps in production, carefully monitored, with just sort of core Docker engine. But after a while of doing that, they start, needing some sense of what's going on across, all these different containerized apps. So they typically, folks revert to a container orchestrator pretty quickly. Pretty quickly probably means like within the first 6 months to maybe 6 to 10 months, right? They realize, oh, I need a container orchestrator to do this. And then container orchestrators work a specific way. So folks tend to basically then spend some time investing in checking out Docker Swarm or checking out Mesos or checking out Kubernetes to basically figure out which one works, the best, which one's best suited to them. All of these orchestrators are opinionated, so that means that they approach the task of container orchestration uniquely. And then once they've done that, then they basically tend to look for enterprise support for that. So if it's, OpenShift, then often they'll come talking to Red Hat, especially if they're an existing RHEL customer. And then they start the POC. And so the POC is often where they start getting serious about their storage requirements. So, it depends. They may have existing storage platforms that they could connect to. They may not. They may have existing storage platforms that they may have, but they're not allowed to connect to because they're already at capacity or in production, and they don't want to affect the I/O throughput of the application. And so at that point, they then would decide, am I going to roll my own storage cluster, deploy a separate cluster, or maybe use container native storage and sort of run it all within the cluster. And so, it depends whether folks have existing storage investments or they're looking for like a net new storage investment. And one of the things that we hear from folks a lot is they like the single control plane. So the ability to sort of, because you're sort of re-platforming a little bit with OpenShift, right? And so you're taking applications, you're building them a different way, and so when you're doing that, it's an opportunity to start afresh with a sort of different approach to how you manage your storage, how you manage your compute, how you manage application density across the cluster, things like that. And so they sort of like the ability to have everything within one control plane on one cluster, still with the ability to sort of scale storage and compute independently, which is kind of unique for like something that's hyper-converged, right? But that's kind of the awesome thing about containers.
Cool.
There was an interesting question earlier on, sorry. Yeah, Eric, I was going to say, maybe can you just throw to a couple of questions that I've seen flow through, because there's some great questions that come around sort of the adoption of enterprise. Look, thanks very much for answering my questions. I appreciate that. I'm going to get Eric to run through some of the questions we've got from the audience, because we've had great questions come through.
Yeah, and here's one just real quick. I kind of heard you comment on this, Stephen, but one of the attendees is asking, can we use this approach for applications in production right now? And I'm guessing the short answer is yes. The longer answer is you're going to want to do some test environments and make sure everything works the way you want it to work before just swapping out traditional database storage for production applications, right?
Yeah, I think you know, what you want to do is sort of segment your applications into sort of classes of applications. So some things work really well right now in OpenShift and Kubernetes, which is you know, web scale or web-based workloads. So you know, we have a web server and it's a scale-out web server. It's a load balance web server. You know, there's a service that acts as a load balancer or a proxy in front of it. You know, it's something that does routing. You know, that works really well. There are, you know, databases. I saw the question on databases. Folks do run databases on Kubernetes. So it has persistent storage support, right? So you can persist so this is the cool thing, like you can create a database and you can use Kubernetes storage mechanisms called the persistent storage framework to basically attach some storage into the container. It's a network mount of storage. It's network storage mounted into the container. You can, you know, have your application run for a number of hours, you know, populate the database with data, and then you can actually kill the application, and the system can schedule that container application on another node 5 hours later, and it'll be able to reconnect to the same backend storage, and your database will come back holistically unaffected. So Kubernetes actually manages things like locking and unlocking, or fencing and unfencing is another way to describe that. So there are folks running like typical 3-tier web applications in Kubernetes. There are also folks that run like Redis and Cassandra in Kubernetes. But as you start heading towards sort of more the big data, the scale-out workloads, that is an area that's not as feature-rich as the more traditional web applications. So yes, you can run analytics applications like Spark on Kubernetes. That's something I've personally worked on. And you can run it against distributed file systems from container native storage in Gluster, and that works well. But there's some other sort of analytics frameworks that are a little trickier to get to run. And that's more just a comment on the maturity of the technology today. Kubernetes is by far the fastest advancing container orchestrator technology out there. So, you know, it's like that weather joke, you know, if you don't like the weather in Texas, just wait a while and it will change, sort of thing. Like Kubernetes, if you don't feel like it has enough features, just wait like a month and, you know, someone will have built it, you know. Now, obviously, Red Hat, that's the raw Kubernetes technology. Red Hat will then take that, carefully look at the code base, pick out the most stable version of that, and then offer that as a product, right? So we will take Kubernetes and package it and offer a stable commercial version that we will stand behind in the same way that we do that with, you know, the Linux kernel and our RHEL Linux operating system, right? And so OpenShift is a stable version. So if OpenShift supports it, that you can trust that you'll get an SLA support agreement from Red Hat around that technology.
Well, folks, this has been fantastic stuff. We have a lot of great questions that we didn't get to, specific questions. I'll be sure to pass those on to our friends at Red Hat. But as many of you understood, I'm quite sure during this webcast, we really are talking about the very cutting edge of enterprise IT, design, application, architectures, really the whole kit and caboodle in terms of enterprise compute. Everything's changing in very positive ways for the consumer, I have to say. So bottom line is check it out. We'll catch up with you next time, folks. Take care. Bye-bye.